Queues are how computers wait in line. Today we'll cover what a queue actually is, the 4 operations that define it, where queues show up in real software, why a naive Python implementation is secretly O of N and how to fix it, and finally, when a queue is the right tool for the job. A queue follows one rule: first in, first out. Like a line at a coffee shop, the person who got in line first gets served first. New arrivals join the back, and the front always serves first. Here the left end is the front, the right end is the back. That's where things enter. The front is where things leave. For operations, define a queue. Enqueue adds an item to the back. Dequeue removes and returns the front item. Peek looks at the front without removing it. And is empty tells you if there's anything waiting. Done right, all 4 run in constant time. Done wrong, like using list.pop with index 0 in Python, dequeue silently becomes O of N. We'll see why in a moment. Queues are how systems handle things that can't all happen at once. Print jobs queue up at a shared printer. Web servers queue incoming requests when the workers are busy. Operating systems queue processes for the CPU. Message brokers like Kafka and RabbitMQ are basically distributed queues at scale. And breadth-first search through a graph or tree is just a queue pretending to be an algorithm, the mirror of stacks and DFS. The obvious Python queue uses a list. Enqueue is append. Fast, O of 1. But dequeue calls pop with index 0, and that's O of N. Every other element has to shift down by 1 slot in memory. With 1,000 items waiting, every dequeue does 1,000 moves. This works for tiny queues, but it scales terribly. Real code shouldn't ship this. The fix is collections.deque, a double-ended queue backed by a doubly linked list of fixed-size blocks. Append is O of 1. Pop left is O of 1. Both ends are first-class citizens. This is what production Python code uses for any non-trivial queue. If you need it thread-safe between producers and consumers, reach for queue.deque instead. Same idea, with locking built in. When should you reach for a queue? Use one for first-in, first-out processing, tasks, requests, messages. Use one for breadth-first search, through graphs and trees. Use one for buffering between a fast producer and a slow consumer. Avoid queues when you need last in, first out. That's a stack. And avoid them when priority matters more than arrival order. That's a heap, which we'll cover next. Queues are stacks twin, same simplicity, opposite order. Once you spot the FIFO pattern, you'll see it across every system you build, from REST APIs to distributed pipelines. Next up, heaps. Same idea as queues, but with a priority. The most urgent item gets served first, no matter when it arrived.